take a look at factoring by grouping and factoring out a common binomial. Now, factoring by grouping is generally used for factoring polynomials that have 4 terms, and it's used a bit in one of the methods that we're going to learn for factoring trinomials. Now, the first thing I want to do is kind of recall what factoring is about. So let's take a look at an example of an expression. Let's say maybe 5xy plus 6y. So what I want to do with this expression is factor out any common factors that I see. Well, in these two terms, both of them have a y, so I can factor out and undistribute a y from both of them. Essentially, I'm dividing this out. So when I divide out that y, this term becomes 5x, and when I divide out that y, this term becomes 6. So what I've done is taken this expression and written it in a slightly different form by factoring out this y that they both had in common. Now we're going to take a look at some factoring that involves expressions that are just a little bit more complicated. So here is another example, and we're going to be looking at a common binomial. So here is another expression, x times the quantity x plus 2 plus 5 times the quantity x plus 2. Now really there are two sort of terms going on here. This first x times x plus 2, that's a term, and 5 times x plus 2, that's its own term. So basically I want to see what do these have in common with each other, a common factor that I can factor out from both. Well, both of these have this quantity x plus 2, so just like we factored out the y in the last example, we're going to factor out x plus 2. Whatever you're factoring out, you're writing that on the outside of some parentheses. So I'm taking this factor and I'm bringing it out, I'm factoring it out. What am I left with when I factor that out from each? Well, I started with x plus 2 here and factored that out, so I'm left with this x plus I had this 5 here, I factored out the x plus 2, and so I have 5. In a way, because these quantities are in parentheses, this is grouped together as one factor, and this is grouped together as one factor. So just like we could take these out as if they were just a variable like y, all I'm doing is I'm taking that out, but it's just an x plus 2. So essentially we can factor out binomials that terms have in common, just like we could with numbers or with singular variables. So for example, if I have 5x times x plus 7 plus 2 times x plus 7, well, those two terms have this common factor of x, this quantity x plus 7. And you can tell that they have that in common because of the parentheses. So it's parentheses x plus 7. That is its own quantity. So I'm going to divide out that x plus 7, factor it out to the outside of some parentheses. And what do I have left? Well, I had 5x, took that away, so now I have 5x. I had 2, took that away, so now I have plus 2. So I factored out the x plus 7, and I'm left in this quantity with 5x plus 2. Take a look at another one here, and switch something up just a little bit. So let's say I have y times y minus 3 plus 2 times 3 minus y. Now these two have a quantity that's very close to being the same. This is y minus 3, and that has the same numbers and variables, but it's switched around. So basically, if this were a y minus 3, I could factor it out. Well, if the numbers are the same and really just the signs are off, what I want to do is factor from this quantity a negative 1. And what that's going to do, if I factor out a negative 1, changes that 2 out there to negative 2, that'll change this. 3 divided by negative 1 is negative 3. Negative y divided by negative 1 is positive y. So by factoring out this negative 1, now I've made that y positive and that 3 negative, just like we see here. And because addition is commutative, I can take the negative 3 and the y and switch those around and make that y minus 3. So by factoring out that negative 1 and changing those signs, now I have y minus 3 and y minus 3. So we'll go ahead and factor out that quantity, y minus 3, and that leaves us with y minus 2. So this factored down to y minus 3 times y minus 2. So here's where this is going to be helpful. By factoring by grouping, we're looking at factoring, in general, 4-term polynomials. So the steps that you can take in this are to, number one, write your terms in order by power, from biggest power to smallest power. Then you'll want to factor the GCF from the first two terms and the GCF from the last two terms. That should give you a common binomial if it can be factored this way, and so factor that out. Then you can check your solution by multiplying it back out, and you should get the same expression that you started with. So here's an example. 5x to the third plus 10x squared plus 11x plus 22. First thing to notice about this is that it is a polynomial with 4 terms. So 4-term polynomials, some of them can be factored by grouping. First thing you want to check for, make sure that those are in order in terms of powers. So I have the powers are 3, 2, 1, and nothing, so they go in order in terms of powers. Once they're in order, take a look at the first 2 terms that you see. And what's the GCF of those first 2 terms? Well, 5 goes into 5 and 10, so the GCF is 5. And both of them have an x, and I can take at most x squared from both of those terms. So the GCF of these first 2 terms is 5x, and I want to go ahead and factor that out. So I have 5x squared, and that's going to leave me with x plus 2, and I factored out the GCF from the first 2 terms. I want to do the same thing here with these last 2 terms, 11x and 22. Well, 11 goes into both of those, it divides those evenly. So I'm going to go ahead and factor out a positive 11. When I divide that out, I get x. 22 divided by 11 is 2, and so I've factored out the GCF from the last 2. Just kind of taking this polynomial in 2 different parts, factoring out the GCF from that left part, factoring out the GCF from that right part. Just rewriting those 2 parts. What that accomplished is now we have a common binomial of x plus 2, so we can factor that out, and we have x plus 2 times 5x squared plus 11. Now to make sure that this is right, you can multiply this back through and you should get the same answer you started with. So just to check and make sure this is right, let's go ahead and multiply this out. So x times 5x squared is 5x to the third. X times 11 is 11x. 2 times 5x squared is 10x squared, and 2 times 11 is 22. And if we put this all back in order, we have 5x to the third. Bring that 10x squared next, that 11x over here, and the 22. So it was the same thing we started with. So this is the factored form. We've just taken this expanded polynomial and written it out in this factored form. All right, let's take a look at another. So here we have 3y to the third plus 20 plus 15y squared plus 4y. So first thing to notice, we have a 4-term polynomial, so grouping is a good strategy to use. Now if we first take a look at these as they are, the GCF of these first 2 terms, well, 3 and 20, those are co-prime, so only 1 goes into both of those. And that is a y, and that doesn't. So really, we can only take a 1 out of those first 2 terms. If we did that, it would give us 1 times 3y to the third plus 20. Nothing really happened. These last 2 here, we have a common factor of y, but we don't have a common factor for 15 and 4, so we can bring out a y, and that'll give us 15y plus 4, and that did not give us the same binomial. If you're going to factor by grouping, you need a common binomial here and here, but they're not the same. If you take a look at how this problem was presented, the reason why is that it's all out of order. So let's go back in there and put this polynomial in order, with the powers going from largest to smallest. So the largest power is 3y to the third. Next largest power is 15y squared. Next one is going to be 4y, and next one is going to be 20. So let's try this again now that we have this in order. So 3y to the third and 15y. Well, 3 divides both of those numbers, and I could take at most y squared from both. And from the last 2, 4 is a common factor of 4 and 20. And that has a y that doesn't, so we can't take any y's out. That's fine. So first 2 terms, I'm going to divide out 3y squared. And that's going to leave me with y plus, let's see, 15 divided by 3 is 5. And out of the last 2, I'm going to divide out a positive 4, and that's going to leave us with y plus 5. So now that we got everything all in order, we factored by grouping, and now we do have a common binomial. So this is not the finished answer yet. We have not completed factoring because this is not a factored form, because this is still written in terms of addition, and we want it written in terms of multiplication. So factor out that y plus 5, your common binomial. That leaves you with 3y squared plus 4, and now that is in factored form because it is in terms of this quantity times this quantity.